Hey everyone, today I'll be showing you how to use the Bazel query language to see the reverse dependencies and dependencies of certain targets in your Bazel projects. And this is a really useful tool, especially when you're in large projects, because at times you find yourself making modifications to certain code that has parents or children that this modifications can actually affect and cause production issues if you're not aware of. So these two queries I'm going to show in this video are a really useful way to make sure that you're really careful when modifying files in your project and to make sure you don't introduce errors in your dependency graph. As you can see here in my project, I have 3 builds, and this is sort of how they're related to one another. So we have user input 2 that relies upon user input that relies upon calculator. Now we don't have to go into the aspects of the code too much, just know that the dependency graph kind of works like this. And this is obviously very small, but imagine if you had a really large project and this thing can just get so massive and you could oftentimes not really visualize it like this. But luckily with this small project we can see, but we're just gonna do something on a small scale right now to show you guys how this works on the large scale, because this will be able to scale up really well when doing this process. Now before jumping into it, really quickly looking over this code, we have, as I mentioned, that user input 2 relies upon user input, which relies upon calculator. And we could see here that user input many nums.py indeed takes multiply multiple numbers from user input mult, which is this file, and this file takes a calculator class from in the calculator folder from calculator.py. So it's that simple. It's just this upstream function takes a downstream function from user input, which then takes a class all the way downstream from calculator. And overall, this allows the user to input multiple numbers to then multiply together to show them on the screen what are the cumulative multiplication of all of these numbers. So it's a really simple program, but I just want to go over that real quick before I jump into the query. So what I'm trying to do is pretty much say, if I modify calculator, what do I have to be careful of in the upstream graph when I do this modification? And that's something called reverse dependencies. So these 2 builds are actually reverse dependencies of calculator. And this is actually a really useful concept when you're in these big projects, because these reverse dependencies can be on the order of hundreds or thousands. And in order to do that, as I mentioned, we use something called Rdeps, which is in the Bazel query language, that allows us to see exactly what are the reverse dependencies of calculator here. Looking at the Bazel website where they define the definition of Rdeps, it takes in 2 arguments, and it can actually take in a third, which is depth, which I haven't worked with yet, but you guys can read about that. But what it says is the Rdeps operator evaluates to the reverse dependencies of the argument set X within the transitive closure of the universe set U. And that can seem really confusing at first, but it's really not once you see like what I'm about to do in a second. But what it pretty much means is we're inquiring about what are the reverse dependencies of this variable within this scope. So scope can mean a certain directory, target, and you'll see shortly right now how that scope is defined. In order to see the reverse dependencies of calculator, it's really simple. I already typed it in before, but I just pretty much write Bazel query, and in quotes I write Rdeps. And then you have here is pretty much you want the 3 dots symbol that we want all of the reverse dependencies. And on the right is what we want the reverse dependencies of. So we want the reverse dependencies of projects, calculator, which is what we're looking for. And if we go ahead and type that in, it'll be really quick right now because I already typed it in beforehand, but we could see that it's dependent on, or the reverse dependencies are user input add, which is a function in user input, user input multiply, which is another function in user input, as you could see here. And then even further up in the graph, we have user input mult many nums. I know that's a bad name for a function, but it's the only thing I could think of at the top of my head when I was making this. And that shows us really easy like what we have to be careful of when we make modifications to calculator. So this is a really powerful query. What we can further do is refine this query. So now imagine I don't want all the reverse dependencies. I just want the reverse dependencies in a specific target. So as opposed to doing these 3 dots, I could just type this, projects, and I want the reverse dependencies in the user input target. So I could just do this, user input, and I want all of the reverse dependencies in user input that rely upon calculator. So I'm just going to enter that in. And we could see, as opposed to showing us further up the graph, it only shows us user input add. in user input multiply. So we can really refine this if we don't want to overwhelm ourselves with like a big list of information, because at times when the project is big, you'll see that this can be hundreds of lines of reverse dependencies. Now we can do the opposite. Imagine I am working with user input 2 and I want to see all of the dependencies of user input 2. And as we can know from this graph, it's user input and calculator. But in a big project, again, it's really hard to visualize that. So as opposed to writing reverse dependencies, we could just write deps. And we don't need 2 arguments for this one. We actually only need 1 argument. In order to do that, I'm just going to Bazel query. I'm going to remove the R and just write deps. So it would be projects user input 2 and then star. And we could see all the dependencies. We have these other things that we don't really care about, but what we do care about in this case is user input multiply, calculator, and other files that we have in that folder as well. And this just gives us a really nice and simple way to see the dependencies of this target, because if we find a bug in this target, maybe we can better analyze what is causing that bug, or we can make sure that if we do make modifications to user input 2 and it takes inputs from its dependencies, we want to make sure that they're still compatible in a certain way. I hope you guys see the power of those 2 specific queries using the Bazel query language for Rdeps and Deps to really gauge the scope of the modification you'd make to a specific target in a Bazel project, and to allow you to see the repercussions of making a modification. And also I want to thank YouTuber Chris Foster. He has a great tutorial on getting Bazel set up with Python. So I'm going to link that in the video description below, because it's a really great video that helped me make this video and helped me just in general with Bazel. So I really recommend watching that. I hope you guys like, comment, subscribe. Keep tuning into the YouTube channel, because I'm going to do more things with Bazel, Python, and React. Let me know what you guys want to see in the comments. And thanks for watching again. Take it easy.